Hey, welcome back to Math with Patrick. Today is February 20th, and we have problem number 51 from this Daily Epsilon calendar to try to solve. All right, it's an arithmetic problem, so we're going to be doing stuff with exponents and factorials, fractions, square roots, and apparently this number is just 20. All right, so when solving these things, generally it's best to solve the numerator, solve the denominator, and then try to simplify. And supposedly we'll get 20 at the end. And following my order of operations, I should solve stuff inside of parentheses first, and that's what I will look at. So I have 5 to the power of 0 plus 4 factorial. Now, anything to the power of 0 is just 1. Well, not everything. 0 to the power of 0 is undefined. There really isn't a good way to assign a value to that. But this one, it does have a value, and it's 1. And one way to think about it is I'm essentially multiplying no 5s together. And if you want to do something with no multiplication, well, it's better to think of that as a 1 instead of a 0. Because if you did something times 0, well, you're actually changing the value. So whenever you see an exponent of 0, that's like doing no multiplication. And so this is a number 1. And with that 4, with the exclamation point, that is 4 factorial. And a factorial is defined as just a repeated product of all the lower whole numbers. Well, hold on, 0 is a whole number. So let's say all the lower natural numbers. So 4 factorial is just 4 times 3 times 2 times 1. I know this times 1 doesn't really do much, but it's just usually defined as such. It goes all the way down to 1. And if we run through that multiplication, we get 12, 24, and still 24. So 4 factorial is the same as the number 24. All right, now I see the square root. And how about let me just write out all my steps one by one. So I did enough, right? I changed 2 of the numbers. Let me do something different in my next step. So the 1 plus 24 makes a 25. And the square root of 25 is just 5. That's because 5 times 5 is 25. And so working backwards, the square root of 25 is 5. And all of that had these parentheses around it with a factorial. But since I just have a number now, it's just the number 5, I don't really need those parentheses anymore. And so now I have 5 factorial over 3 factorial. Let's just go back to that definition of factorials. 5 factorial is going to be 5 times 4 times 3 times 2 times 1. And then 3 factorial is going to be 3 times 2 times 1. And generally, when you're doing arithmetic with fractions, it's best practice to solve the top, then solve the bottom, then do the division. Though if we have repeated factors on the top and bottom, these ones can just cancel. And I'm left with nothing on the bottom. And again, a 0 is not the right number to put here because we're multiplying and dividing. A better number for nothing for multiplication and division is a 1. And this is the idea behind simplifying dividing factorials, where I think for me, I just like to write it out as 5 times 4 times 3 factorial over 3 factorial. Like this is what I would do just kind of on my own. If I'm dealing with these factorials, I just cross them out like this. But I guess I also wanted to write it out to explain why you can, because we're just crossing off the same factor on the top and bottom of a fraction. And of course, like I said earlier, I'm not left with a 0 in the denominator. I'm left with a 1. And here it's pretty easy to see that I have the number 20. 5 times 4 is 20. Dividing by 1 doesn't do much at all. And so we get our answer for today. So all in all, this number was just 20 all along. And maybe you heard that Quill was scratching at my chair. I think he was saying something along the lines of he missed being on camera. So here he is again. Quill, do you think the answer is 20? I think he does. So thanks for coming along, solving this problem with me. And I'll see you tomorrow. All right. Bye.